Hi, this is a short video on multiplying decimals. Now, all of the work in here is going to be done with positive decimals, but of course the same rules for multiplying integers holds. For example, positive times a negative is a negative, negative times a negative is positive, etc. So first one we're going to take a look at is 5/10 times 6/10, and we'll look at first from the perspective of a 100 grid. And so 0.5 or 5/10, this is essentially like a flat, right? One grid equals 1. So 5/10, we would shade that in. Right? 5, 2, 3, 4, 5. And just like we did in class with the piece of paper where we then folded it the other way and then shaded, so we're going to do that with the 0.6, the 6/10. And so we're going to go ahead and do that with some red and do this way. 3, 4, 5, and 6. And so if we take a look at the section here that is in fact shaded both red and green, that's this section here. And if we count those, that is 30, right? So 30 out of 100. And if we convert that to a decimal, that's 30/100ths, which is 0.30. Okay. So we are normally told, okay, well, if you're going to multiply decimals, you just basically multiply them as if there was no decimal. And then at the end, you count the number of decimal places and you move the decimal over that number of places. Well, why, right? Why does that algorithm work? Where does that algorithm come from? So let's take a look at this same problem, but written as fractions. Okay. And the way that we multiply fractions is we multiply across the numerator. So 5 times 6 is 30. And then 10 times 10 is 100. So if we then converted that to a decimal, we'd again get 0.30 or 30/100ths. Well, notice what happened here. What was our first step that we did? We first multiplied the 5 and the 6 to get the 30, right? So essentially ignoring the decimals and getting 30. And then the second step that we did was what? Multiply the 10 and the 10, which represented one decimal place each, to get 100, which gives us the 2 decimal places. So we added the decimal places together to get the 0.30, right? We moved it 2 decimal places. All right, so let's take a look at this next problem, which is a little bit more complicated. 2 3/100ths times 9/10. And so again, normally what we would do, and we'll see what that looks like, is, again, the instructions, the standard algorithm is just multiply as if there were no decimals, ignoring, right, the 0 out in front, and then count up the number of decimal places and then move, right? So 9 times 3 is 27. Oops, that's not where the 2 goes. 7 goes there. 2, 9 times 0 is 0, plus 2. 2 times 9 is 18, and there were a total of 1, 2, 3 decimal places. So I move my decimal place 1, 2, 3 places to the left, and so my answer is 1 827 thousandths. Okay, so let's dig a little deeper to see where that's coming from. So the 2 3/100ths is, when we make that an improper fraction, that's going to be 203/100. So we take that number, which represents 2.03, or 2 3/100ths, which has 2 decimal places, times the 9/10ths, which has 1 decimal place. So again, what we do first is just multiply the numerators together. Guess what that number is? 1,827. And then what do? We multiply the denominators together. And what do we get? 1,000. So if we convert 1,827 over 1,000, we get 1.827. So that's why that algorithm holds, that you just go ahead and multiply as if there are no decimals, get your result, and then count the number of decimal places you have and move over. Because that's essentially what's happening underneath when you do it as fractions, when you do that multiplication in equivalent fraction form.